here we have the ear. The outer part of the ear acts like a funnel. This outer part of the ear is called the pinna, or the auricle. You have the ear lobe, the lobule, and then you also have the helix, or the rim of the ear. That's going to funnel, capture sound waves, which will travel back through the ear canal, which is called the external acoustic meatus, which will then vibrate the tympanic membrane, or the eardrum. And pull this out here so we can see that tympanic membrane. It is a membrane, so it is a clear membrane with blood flow to it there. See the back side of the tympanic membrane, the eardrum. As sound waves come back through the ear canal, the external acoustic meatus, they will then vibrate that tympanic membrane, which will then cause the ossicles, the ear bones, to be able to move, which are the malleus, incus, and stapes. Here we can see the malleus, which looks like a hammer, the incus, which looks like an anvil, and then we also have the stapes, which looks like a stirrup. Unfortunately, our stapes is somewhat broke. You can see a piece of it here. This would come down to form the stirrup of the stapes. The stapes is going to be up next to this oval here. That's the oval window, which will push the fluid inside of the snail shell cochlea here. As that fluid moves through the cochlea, that's what bends the hair cells. That will create the action potential for you to hear. And you can see that cochlear nerve coming out the back of the cochlea. We also have the eustachian tube, or pharyngotympanic tube here, which will connect the pharynx to the tympanic membrane. We have the semicircular canals. And then you also have this egg-shaped vestibule at the base of those semicircular canals. And again, you can see the snail shell cochlea. So again, we have the auricle, external acoustic meatus, tympanic membrane, malleus, incus, and stapes, with the oval window. You have the vestibule, the cochlea, semicircular canals, and the cochlear nerve, which would help to join that vestibulocochlear nerve.